Okay guys, today we will talk about aluminum. Aluminum is a topic I've covered in my bachelor thesis a lot. So I've dealt with and I've researched how aluminum is produced, how our greenhouse gas is produced during the aluminum production, and also how can we reduce the greenhouse gas emissions during the aluminum production. And the thing is, during my research I've not found anyone who condensed this topic as I wanted it or as I needed it. So I had to put a lot of effort in to research all these things for myself to get an overview. And I think it is really helpful for you if I use my knowledge that I've gained for you to easily explain how our greenhouse gases produced during the aluminum production, where do they come from, and also how the greenhouse gases are distributed. So what processes are most important in the carbon footprint of aluminum production. And so in the end we can also explain what reduction measures do we have and why do they function and how do they function. Yeah, and this is what I want to show you today. So we will first talk about the steps of the aluminum production. We will talk about the greenhouse gas sources of each step. And we will talk about the distribution of greenhouse gas emissions, so which step is the most important, and in the end we get the reduction measures. Starting off with a short motivation. Why do we even care about aluminum? So aluminum is the second highest metal in demand after steel, and it has high CO2 emissions. So about 1% of the global emissions in 2021 are contributed by the aluminum industry. And this demand will further increase, so we have to do something about it. So that you know what I want to talk about, we will start with this figure. We get along this figure in the following video, where we explain all these steps. These are the basic steps how aluminum is produced, starting with mining the raw material, bauxite, refining this bauxite to alumina, which can then turn into aluminum in the smelter, and the raw material or raw aluminum is then casted. So we will start off with bauxite mining. Bauxite is the raw material for aluminum. It's like a mineral where aluminum is inside, and it looks like this. So it's like a red or brownish like dirt. Bauxite is mostly common in tropical regions, also just a few meters below the ground. So we can mine this in an open pit mine because we don't have to drill deep down, and we also have to use these machineries or special vehicles like shown here. So in the end we have the raw material bauxite, which is mined in an open cast mining. We need fossil fuels for the vehicles and the machinery, but in the end this is only a small fraction of the total production emissions, so 0.2% is really not much. So then we have our bauxite, then our red bauxite or raw material, and we want to produce alumina now. Alumina is like the transition point between bauxite and aluminum, and we do that during the alumina refining process. This alumina refining process is typically done by the Bayer process, which looks a bit like this. Don't worry, we don't have to cover all of these steps. What you have to know is this bauxite gets in, gets treated, and comes out as this white powder. The thing is, during this alumina refining we need high pressure and also high temperatures. And these high temperatures then demand high energy and high amount of energy, and this high energy demand is often met by fossil fuels. So in the end we have like 11.6% of the total emissions in the aluminum production are contributed by the alumina refining, which is mainly due to fossil fuel energy use. So we now transform the bauxite into alumina during alumina refining, but in the end we want aluminum like we all know it. It looks like this. And to achieve that we go into the smelter electrolysis. Don't worry, we cover it easily, I will explain it. Smelter electrolysis looks a bit like this. So we have just giant industry halls where a lot of these cells are placed. And these cells look in the inside a bit like this. So we have the carbon anodes, which is like the positive charge here. We have carbon cathode, which is like a negative charge at the bottom. And in the middle there's an electrolyte. And electrolyte basically is just a liquid that allow electrons to travel. So this is like just a connection between positive and negative that electricity can flow. So the cell itself is just basically a big pot where the bottom is negatively charged, and we have like these sticks from the top which are like positively charged. And what happens now is our alumina that we have just produced gets thrown into the electrolyte, and there the alumina dissolves. Then we add a huge amount of electricity. So 5 volts is not much, but 200,000 amps is really a lot. It needs a lot of electricity. And when we do that, the aluminum oxide, splits into aluminum ions and oxygen ions. And based on the charge, these aluminum ions go to the negatively cathode, and the negative oxygen ions go to the positive positive anode. They travel here. The thing what happens now is, because we use anodes made out of carbon, this oxygen reacts with the carbon and forms CO2. And this CO2 is then exits the cell then as waste gas, as emission, and also the molten aluminum is extracted like through a pipe, like sucking it out. So we have CO2 as waste gas, but there's more, because the electrolyte, which is like this, is cryolite, and it has the chemical formula shown here. The important thing is that there's fluor inside, and this can also react with the carbon anodes, or with the carbon from the carbon anodes, during a so-called anode effect, and so-called PFCs are formed. So these are gases that have like carbon and fluor with CF4 or C2F6. And these gases also exit the cell as waste gases. So these gases are only produced in a smaller amount during the production, because they are only at these specific anode effects, but they matter. And why they matter I will show you on the next slide. So 1 kilogram of CO2 has the equivalent impact of 1 kilogram CO2. I think that's self-explaining. But if we look at these PFCs, we have 1 kilogram of CF4 is as impactful or as strong as a greenhouse gas, like 6,630 kilograms of CO2, and C2F6 is even stronger, with 1 kilogram of this chemical is as strong as a greenhouse gas as 11,000 kilograms of CO2. So we have to consider them because they are so strong, even if they are only produced in a small amount. So we have these CO2 emissions from the electrolysis, and we have also these PFC emissions. In the end, when we go to the smelter electrolysis, like I said, we have these two as main emissions, but also keep in mind the high electricity demand that I mentioned. Because if we now go to the smelter electrolysis and look at the greenhouse gas distribution, we can see the Alumina Refining here. And now the very high electricity demand is often met by fossil fuels, mainly by coal and also natural gas. So in the end, because there's so much electricity that is met by fossil fuels, the electricity actually takes up 66% of the total emissions during the aluminum production. It's like a big chunk. Also, we have the CO2 emissions I have explained, because the oxygen from the alumina reacts with the carbon anode to CO2, and these emissions take up also 11.6% of the total emissions. And in the end, the PFCs I've mentioned are responsible for around 5% of the total emissions in the aluminum production. So they are also important. Yeah, getting further in the production chain, so we now have these waste gases and also the molten aluminum. And so the last step is ingot casting, where this aluminum is just casted into the form we want. So there's not much interesting stuff for us to cover here. So we can just neglect that from the environmental perspective in the bigger picture. Now, as we get back to the whole figure, I hope you now understand why this heat map is as it is, with alumina refining and the smelter electrolysis as the main components, with energy and CO2 and PFC, and the carbon anodes and electricity as the main components. And in the end, I've shown this is the greenhouse gas distribution, and we can also add other components. So there are other greenhouse gas sources, but they are in comparison relatively small, so they are just summed up in this other category. Okay, so now that we have this information, we can ask ourselves, how can we reduce the greenhouse gas emissions in the aluminum industry? And we can start by looking at the biggest leverage, so the biggest chunk, it's electricity. So by applying renewable electricity, applying renewable energy, we can reduce this part very much. But we have to keep in mind this effect depends on the energy source. So for example, if we replace coal energy with solar energy, we can reduce a lot. But if, for example, the company uses already wind energy, solar panels won't reduce much emissions. So it depends on the energy sources used. Also, we have to keep in mind the aluminum production needs a constant energy supply. This is necessary because otherwise the production would experience a total failure and everything would break. So this is why hydropower was often used as a renewable energy source, because this is like very constant. But it depends on the circumstances if we can do that. So if we have aluminum production in Saudi Arabia, hydropower is difficult. So it depends on the circumstances how we can apply that. The other part we can reduce, the other big part, were the CO2 and PFC emissions because of the carbon anode. And we can switch that by using anodes that are not made of carbon, but they are made of metals or ceramics. So in the end there's no carbon to react with the oxygen or the fluor, and so no CO2 and no PFCs are produced, and this can reduce this part. The downside on this part is that some people claim that these anodes increase the electricity demand, and so if we have an electricity mix that is mainly dominated by coal, using more electricity could eat up the benefit, and so in the end you have to individually look how beneficial this is in the end. Okay, and so the next part, or the third part, is here, down here, the alumina refining, which is more deeper in the supply chain, so it's not that easy. But basically we also have to use renewable energy, we can apply hydrogen or biomass, so there's also just about the energy. So these are two things we can do, renewable energy and inert anodes. But there's also one thing that's maybe even better, and that is recycling. Why is aluminum recycling so important? We see it like everywhere. Aluminum recycling, recycled aluminum, recycle your cans and so on. Why is it so important? So aluminum recycling creates 95% less CO2 and consumes less energy. Why is this the case? So by collecting aluminum scrap and just remelting them, we can skip these emission-heavy process steps. So these steps that make up 90% of the aluminum production are just skipped, and so we can reduce 95% of the CO2 emissions. Yeah, and of course these are just the three measures that are most important, but in the end there will be other technologies maybe, or other technologies that are newly discovered that I've not mentioned here, so this is not the only things, so these are not the only things we can do. There are other technologies in development that may help us too. Yeah, and that's it. I hope it was helpful for you. I've tried to make it as easily understandable as possible, because I think it's not that hard to understand, but you just have to have this information condensed. And yeah, I hope this helps you, whether you do a school project or a university project, or just need to know why aluminum is so carbon intensive. And yeah, I hope you learned something from today. And yeah, for more information, you can look up my bachelor thesis. There it is more detailed, and also there are more reduction methods. If you're interested in that, just look there. I put the link down below. Yeah, then see you next time. Thank you for your attention, and bye.